Hello students, once again I welcome you in my YouTube channel and students of class 10. So today in the series I am taking the classes of physics. So today we will go to about the nature of light, because last time we have done the rays of light, beam of light, parallel beam of light, convergent beam and divergent beam of light. We have already finished, and I am planning you to give the question answer also of the chapter. Let me complete the chapter number 1 of the light, then I will give you the question answer also in a separate website. So you can go to the website and you can download the question answer also. So let's start with the nature of light. So students, we will start with the nature of light. Nature of light. Now, according to Sir Isaac Newton, light consists of extremely small particles known as the corpuscles, and these small particles are of different sizes and they move with the same speed in a straight line. So, nature of light, the first nature is according to, we can say that according to, Sir Isaac Newton. According to Sir Isaac Newton, visible light consists of extremely small particles known as the corpuscles. Visible light is what? Visual light is white light. Visual light is made up of small particles small particles known as corpuscles. Known as what? Corpuscles. Small particles known as corpuscles. Now, these small corpuscles are of different sizes. Corpuscles are of different sizes and move with the same speed in a straight line. So we can say that the corpuscles, corpuscles are of different sizes. Corpuscles are of different sizes, and move with the same speed. Move, we can say that, move with same speed in a straight line. In a straight line. So now here, this is very important thing here, that according to Sir Isaac Newton, according to Sir Isaac Newton, we can say that Isaac Newton. Isaac Newton. You see that Isaac Newton. Visible light is made up of very small particles known as the corpuscles, and the corpuscles are of different size and move with same speed in a straight line, right? In a straight line. So this is about Isaac Newton, and there are three natural phenomena, like you can say the formation of shadow, reflection, and refraction of light. It can be explained from the corpuscles theory of light. You see that we can say here we can say you see formation of shadow, right? Formation of shadow. What is a shadow? Formation of shadow. What is shadow? When an opaque object comes in front of light, then it forms its own shadow. No, so formation of this shadow, right? Formation of shadow. Just 1 minute. Okay, so we can say that formation of shadow, then reflection, and reflection and refraction. Okay, refraction of light can be explained by, can be explained by Corpuscle's theory of light. Theory of light. Okay, so student, now here this is another point. This will be point number 1, this will be point number 2. Point number 1, you know that the visible light or white light is made of very small particles known as the corpuscles, and the corpuscles are of different sizes and these corpuscles move with the same speed in a straight line, and the formation of shadow, reflection and refraction of light can be explained by corpuscle theory of light. It has been asked in the question that name three natural phenomena which can be explained by corpuscle theory of light. So 3 natural phenomena which can be explained by the corpuscle theory of light are shadow, reflection and refraction of light. In Hindi, if we see that the 3 किस्म के जो नेचुरल फेनोमेनन है, जैसे शैडो है, रिफ्लेक्शन ऑफ लाइट है, this can be explained by corpuscle theory of light. Then after that we go to the diffraction of light. Students, now we will go to the diffraction of light. After that I will rub this one, and then we go to the, you see that we go to what? We go to the diffraction of light. So now here we clear all. Okay, we will clear all. So now we go to next one, okay, now after that I want to go to, okay, diffraction of light. What is diffraction of light? Okay, diffraction of light. This is also very important. Diffraction of light. So okay, now if we diffraction means what? That if an opaque object of very extremely small size, such as opaque object of extremely small size, it come in the path of light, then the light has a tendency to bend around it. Okay, light has a tendency to bend around it, and this is called as the diffraction of light. So here, suppose if an opaque object stream, suppose we take a shaving blade. Suppose here this is our shaving blade. Okay, suppose here we can say that, okay, this is shaving blade, right? This suppose we can say that this is a shaving blade. Now here this is the razor. No, this is our razor. So razor edge, this is a razor edge. So if the razor edge is placed in the path of light, suppose rays of light is coming from here. Okay, this is rays of light. Rays of light is coming and it will strike at the razor edge of shaving blade. Then this razor edge this is an opaque object. Razor edge is what? Razor edge is an opaque. Razor edge क्या है? ये opaque object है. So the rays of light will come and strike at the razor edge of shaving blade, then the rays of light will bend around it. Okay, rays of light will bend around it. Okay, this will bend. So this is bending of light. Okay, bending of light. Rays of light will bend around it, and this bending of light is called as the diffraction of light. This is called as the bending of light is called as the diffraction of light. Okay, students. So now here I just write. I want to write the definition here. So I just want to clear all. Okay, clear all. So now here diffraction of light once again. Let's write that. Okay, diffraction of light. I have explained already to you diffraction of light. So here, if an opaque object, object of extremely small size, object of extremely small size, okay, small size, extremely small size, such as razor edge, okay, such as razor edge, okay, such as, now here you can say that, such as razor edge of a saving blade, razor edge of a saving blade, okay, razor edge of a saving blade is placed in the path of light, okay, is placed in the path of light, placed in the path of light, then light has a tendency to bend around it, okay, then you see light, okay, light has a tendency to bend around it. Light has a tendency to bend around it. This is called diffraction of light. This is called diffraction of light. Diffraction of light. Okay. It's called diffraction of light. Just 1 minute. I'll show you. This is called, okay, diffraction of light. So here, suppose we can say that this is the blade, okay, this will be the razor edge, no, razor edge of a saving blade, no. So if this will come in the path of light, this light is coming. If it come in path of light, then the light, after striking the razor edge saving blade, light will bend. Okay, light will bend, and this is called as the diffraction of light. This bending of light around it is called as the diffraction of light. This is called as the diffraction of light. Student, now have you understand this one, diffraction of light? So very simple. If an opaque object, just like this is an opaque object. This is a opaque. Okay. This is okay. This is an opaque object. Okay. Now. Okay. Now this is an opaque object here. Okay, opaque objects. So if an opaque object of extremely small size, such as the razor edge of a saving blade, is placed in the path of light, then the light has a tendency to bend around it. The light, when after striking it, the light will bend around it, and this is called as the diffraction of light. Very simple, student. Okay, so after that we go to I'll rub this one, or I'll just, okay, now okay, now students, so now I think you have written already, so let me go and clear all. Okay, clear all. So now scientists have commented on nature of light in the following ways. Okay, now then the scientists okay have commented on nature of light, on nature of light. Scientists have commented on nature of light in the following ways. Okay, students, I want to complete your syllabus because we have started very late in the month of the May. Class 10 students, so we will try to complete it fast. First of all, I will finish the physics, then we will go to chemistry, then biology. Like that we will complete your syllabus. So now here the first scientist was a Dutch scientist, a physicist known as the first was a Dutch physicist was there, a Dutch a Dutch physicist we can say that physicist, his name was Christian Huygens. Okay, his name was Christian Huygens, Huygens, Huygens. Now what he did that he suggested that he suggested the wave theory of light. Okay, Huygens and Huygens and S. No, this is your N. Okay, Huygens suggested wave theory of light. Suggested what? Suggested wave theory of light. Wave theory of light. No. He proposed that light has transverse wave. Okay. He proposed the light has transverse wave. And this wave theory of light. Now what is that? This wave theory of light. This wave theory of light. Okay. Explain the phenomenon of this wave theory of light. Explain the phenomenon of diffraction. Okay, diffraction. Okay, then our interference and polarization of light. And what? And polarization of light. Okay, polarization of light. Now this phenomenon of diffraction, interference and the polarization of light, this was explained by the wave theory of light, and the wave theory of light was suggested by the Dutch physicist Christian Huygens. This one you have to remember. Okay, diffraction, interference and polarization of light. If you go to higher class, then you will study, not in this standard of class 10. And then secondly, okay, secondly secondly I can say that okay, in the year 1801, what happened there? In 1801, there was another scientist. Okay, Thomas Young. His name was Thomas Young. Okay, experimentally proved wave character of visible light. He experimentally proved what? He experimentally proved wave character of visible light. That means our white light is a visible light, and white light is is made up of the wave. It has a characteristic of the wave. Okay, like of the way, like the visual light is made up of the different colors. Like visual light is our white light made up of the different color or Vibgyor color: violet, indigo, blue, green, yellow, orange, red. And every color has a different wavelength. So there is a wave character of the light, experimentally proved by Thomas Young, and he was able to measure the wavelength and frequency of light. Okay, he was able to measure. He was able to measure what? Able to measure wavelength and frequency of light. Measure wavelength. Okay, wavelength and frequency of light. Wavelength and frequency of light. Okay, he was able to measure the wavelength and frequency of we can say the light. Frequency of light. He was able to measure the wavelength and frequency of light, right? Okay, so now this was the experiment done by the Thomas Young, who told that the light has, who told that the light has wavelength and wavelength and wave character, and he was able to measure the wavelength and frequency of light. So students, so now after that one more thing is that third point we will go to. So now let me rub this one, or let me rub this point now. Okay, now let me clear all. So now number 3 here, what happened there? Albert Einstein, another scientist, his name was Albert Einstein. So here you can say that Albert Einstein, what he did that Albert Einstein used corpuscle theory and explained the photoelectric effect of light. Okay, this is very important. Use corpuscle or corpuscular theory. You can use use the corpuscular theory of light. Okay. Albert Einstein used corpuscular theory of light and explained the photoelectric effect of light. Photoelectric effect of light. Photoelectric effect of light. Light. Photoelectric effect of light. Photoelectric effect of light. So now then last one we go to the quantum theory of light. Now next one we have the quantum. What is quantum theory of light? Very, very important. Quantum theory of light. Now this quantum theory of light is very important. According to quantum theory of light behaves like particles as well as a wave, depending upon the situation of it encounter. Okay, light behave as a particle also, light behave as a wave. Now, in the quantum theory of light, what happened? Light behave as a wave and also as particle. As particle. This is light behave as a wave and also as a particle depending upon the situation it encounter. Okay, particle depending upon the situation, it encounter. Okay, encounter. In this theory, each particle of light is called as a quanta. Okay, so here each particle of light, okay, light is called what? Is called quanta. Quanta, quanta. Each particle of light is called as the quanta. Okay, each particle of light is called as the quanta. Quanta. Each particle of light is called as quanta. And the quanta has specific frequency and wavelength. Okay, and you see quanta has specific frequency, frequency and wavelength. Specific frequency and wavelength. Okay, specific frequency and here, okay, and wavelength. Specific frequency and wavelength. So wave, okay, specific frequency and wavelength. No, wavelength. Quanta has a specific frequency and wavelength, and okay. So the quanta travel in vacuum with the same speed of 3 into 10 to the power 8. Okay, it travel. Okay, it travel in vacuum. It travel in vacuum. Okay, with a speed of 3 into 10 to the power 8. Okay, 3 10 to the power 8 meter per second, right? Per second. So this is okay. So the quantum theory of light. What the quantum theory of light states there? Light behave as a wave also and also as the particles depending upon the situation it encounter. Encounter, depending upon the situation it encounter. Okay, depending upon the situation it encounter. Encounter. Okay, then second one, each particle of light is called as the quanta, right? Each particle, light is made up of quanta, just like we can say that kilogram is made up of gram. Okay, similarly the light is a electromagnetic wave, we know that, and it's made up of the quanta. The quantity of light is called as the quanta, and the quanta has specific frequency and wavelength, right? And frequency and wavelength, right? Wavelength is the length of the wave of light, and frequency is okay, how many number of times it will frequently strike on a surface, and then it travels in vacuum with a speed of 3 into 10 to the power 8 meter per second. Okay, last one, we go to the visible light. Now last part of the topic is the visible lights. So let me clear it all. Okay, so let me clear it now. Okay, so last part is our visible light. I will go to the visible light is what? Visible light is our white light. No, white light is called as the visible light. So student, see, white light is called visible light, and it is a narrow band of electromagnetic radiation. Okay, it is a narrow band of electromagnetic radiation. It is a narrow. Okay, it is a Okay, narrow band of, it is a narrow band of electromagnetic radiation. It is a narrow band of electromagnetic radiation. Okay. Now its range. What is the range of visible light? Range of visible light. Sometimes they ask in the exam. What is the range of visible light? Okay. So we can say that a wavelength 4 into 10 to the power 7 meter. Okay, this is up to the 7 into 10 to the power minus 7 meter. This is for the wavelength of the violet. Okay, this is what? Wavelength of violet. Okay, wavelength of violet, and here this is wavelength of red. Okay, in between we can, this is our visible light. This is the range of the visible light. So visible light, it is a narrow band of electromagnetic radiation, we know that. And then range of visible light is 4 into 10 to the power 7 meter to the wavelength of violet light. ये wavelength of violet light का है, और 7 into 10 to the power minus 7 मीटर ये है wavelength of red light. ठीक है, तो इसके जो बीच में जो भी wavelength है वो visible light का है. That is that between the wavelength of violet light and the wavelength of red light exists the wavelength of visible light. Hello students, so this range of visible light, with this we come to end of the nature of light, and in the next class we will start with the reflection of light. So be ready for that, and we have to complete your course very early, because after I told you, after physics we'll go to chemistry, then biology. So till then you please subscribe my channel so that you can get a new video in the light chapter, and also press the icon bell and share this video to your friends of class 10. Thank you very much for listening.